So example 8 is the same problem as before, except the difference with this one is we're going to deal with much bigger numbers, so we have to be much more careful with our calculation. So it'd be good to use a calculator for this problem. So we have a bed retailer sells double and queen size beds. We have the cost of a certain number of double and queen size beds. And again, I want to make sure that I know what I'm looking for. It says, how much is the cost of a double bed and a queen size bed? So that's going to help me establish my variables. So it says, how much is the cost of the double bed? So I'm going to let X equal cost of double bed. And I'm going to let Y equal the cost of queen size. So it's going to be the cost of queen size bed. Okay, so that's the first thing. I'm going to then establish what are my relationships. So it says I have 20 double and 50 queen cost 61,850. So that's going to be my first equation. It's going to be 20 times the cost of the double beds, so X, plus 50 times the cost of the queen beds, which is Y. And those two costs are going to add up to 61,850. Okay. I need to then come up with a second relationship. And that second relationship is going to be based on the 55 double size beds and the 13 queen size beds costing 46,210. So this is my second equation. I have 55 times the cost of the double size plus 13 times the cost of the queen, and that's going to equal the total cost 46,210. Okay, so in this case here, I think I'm going to do subtraction, and I'm going to try to match up the x coefficients, because again, that 13 makes it awkward to match up the y's, although it's not going to be that much different. We're still going to deal with large numbers. So I'm going to make my lowest common multiple, in this case, is going to be 220. Okay, so the lowest common multiple of 55 and 20. We have the 20 is missing a factor of 11. Okay, so there's 5 times 11. There's a factor of 5 in the 20, so it's missing a factor of 11. So it's going to be 11 times equation 1 gives me 220x plus 550y is equal to, when I multiply that by 11, I get 680,350. Okay. Matching up the x coefficients, I need to multiply equation 2 times 4. Okay, because that's missing a factor of 4. So 55 times 4 gives me the 220x, which I'm looking for, plus, when I work this out, I get 52y, and multiplying the 46,210 by 4, I get $184,840. Okay, so at this point now I've matched the x coefficients. I can subtract these two equations. So the x's cancel out. I'm going to end up with 550y minus 52y. That's 498y. When I subtract these two dollar amounts, I'm going to use my calculator to do this. I get $495, $495,510. I can now solve for y. I'm going to divide both sides by 498. And when I do that, I end up with 995. And that represents the cost of one queen size bed. I still need to work out the cost of the double bed. So I'm going to plug this back into equation 1. Equation 1 looks like a little bit easier to work with. So I'm going to use equation 1. So I want to find x, the cost of a double bed. So I'm going to do 20x plus 50 times the cost of the queen size beds, which I figured out, and that's going to be $995, and that's equal to, I just need to move this over a little bit here, and that's going to be equal to, oops, that will be equal to the original 61,850. Okay, so working this out, 20x plus, this works out to 49,750. That's equal to 61,850. Subtracting 49,700 from both sides, I get 20x is equal to 12,100. So x works out to be $605, and that's the cost for each double bed. Okay. Lastly then, it says determine the number of solutions. So the number of solutions is based on, we have any two lines that have different slopes will intersect once. Okay, that's one possibility. The other possibility is two parallel lines have zero solutions. And the other possibility, the last possibility, is when we have two lines that are coincident, basically one on top of the other, it means that there are infinite solutions, and that's when they have the same slope and they're the same equation. So looking at one, what I'm going to do is I'm going to simplify equation 2 and see what happens. And in fact, when I take equation 2 and I divide out the common factor, so equation 2 has a common factor of, looks like 3. If I divide everything by 3, I get 2x minus 7y minus 10 equals 0. What that means is that these are the same equation. Therefore, we have infinite solutions. Okay, this is when the two graphs graph right on top of each other. Every point is the same, so every point is an intersection. There are infinite solutions here. When I take a look at B, for B, what I'm going to do is look at the ratio of the slopes. Now, the ratio of the A and B. So to do that, first of all, I'm going to rewrite this as negative 2x plus 0.5y plus 5 equals 0. And when I do that, it's a little bit easier to compare the coefficients. So when I look at the coefficients here, I have, in the first equation, I have a negative 3 to 12 ratio. In the second equation, I have a 2 to 0.5 ratio. Well, in this case, the A to B ratio, and I'm going to maybe highlight this one in green. Okay, so the A to B ratio for the green equation is going to be negative 3 to 12, which simplifies to negative 1 to 4. The A to B ratio in the second equation is different. So in this equation, the A to B ratio, coefficient ratio, is negative 2 to 0.5, which I'm going to make it negative 4 to 1. Okay, now although the numbers are the same, they're backwards, so the ratios are different. Okay, so the ratio of A to B is different. And if it is different, that means it has different slopes. So therefore, different slopes. Okay, if they have different slopes, there is one solution. We don't know where it is, but we know it definitely has one solution.